Hi Chem Peeps, this is the last video on Lewis dot structures. I'm going to talk about the trigonal planar and trigonal pyramidal in these two examples. I picked these just because they're a little bit different. Notice that there's a negative charge on there. We could have a positive charge, but when there is a negative charge, that means there's an extra electron that did not come with these atoms from their periodic trends. If it should happen to be positive, that means I'm going to take one electron away from one of the atoms. It doesn't matter which one, but take an electron away. But we're going to do this with an extra electron. So I'm going to put nitrogen in the center. It has 3 bonding sites with 5 valence electrons. And then I'm going to put an oxygen on the 3 sites here. Now, oxygen has 6 valence electrons, and I did not put my extra electron in, so I'm going to put it right here. It doesn't matter where I put it, but I'm going to put it right here and form a single bond between the nitrogen and oxygen. Each oxygen still has 6 coming into the molecule, and I'm going to put that there, and I think what I'm going to do, I have one more here. I think what I'm going to do is I'm going to form what's called a coordinate covalent. And you're like, what? That's when one atom donates both electrons in the bond. See, oxygen needs another electron here, and it's got to get it from the nitrogen. So what I'm going to do, I'm going to erase the one up here and erase the one that oxygen gave, and I'm going to let oxygen keep its 6, and nitrogen's 1 electron from the top is going to go here. So what's going to happen here is we're forming a single bond there, but both electrons came from the nitrogen. This is called a coordinate covalent bond, and they're real, okay? Electrons look the same no matter where they come from. So I'm going to create a coordinate covalent. Now, oxygen here has 6 valence electrons, and nitrogen has 2 left that it can use in bonding. But nitrogen's not going to be happy with a single bond, because if it forms a single bond, it's going to have 2 electrons in the first bond, 2 electrons in the second bond, and then 2 electrons in the third bond. That's only 6. It wants 8. The goal is to get 8, to be an octet like the noble gases. So what I'm going to do is I'm going to move this one down. Okay, so I'm going to erase this, and I'm going to put it right here. But I can't form what I did below with a coordinate covalent because it will not give enough for the nitrogen. Oxygen would be happy with that because oxygen, this oxygen right here would get 8, but nitrogen is not going to be enough. So we're going to move 2 electrons over into the bonding area between the atoms right here. That's going to form a double bond. Now, I know this is correct because there is 8 valence electrons around each atom in this structure. Now, I need to tell my reader I do not have to make this look different than the other electrons, but I need to tell my reader that there's an extra electron by putting brackets around it with a negative charge. Okay? So what shape would this be? Well, there are 3 bonds coming out of the nitrogen. This is trigonal planar. And it's planar because there are no spare electrons, unshared electrons up here to push the bonds down. So this would be 120 degrees. And since I have oxygen pulling in all directions, this would be, well, it's not going to be nonpolar. I want to say it's nonpolar, but I have this extra electron, so it's going to be polar. So I gotta include that. Okay, so let's look at the next one. We have carbon. Carbon has 4 valence electrons. I'm going to put the 4 around there. And you can see we have an extra one here. Hydrogen has 1 valence electron. And remember, hydrogen, when it bonds, gets 2 like helium. So these 3 hydrogens are happy with their 2 electrons. I have not shown my extra electron. I'm going to put it right there, so that I have a pair of unshared electrons there. I do need to tell my reader that it is negative because there's an extra electron there. The bonds, this cloud of electrons here, okay, is going to push down on these bonds and form like a pyramid. So this is trigonal pyramidal. it's always, 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 always going to be polar. And the reason it's always going to be polar, whether I have an extra electron or not, is because of this unshared pair of electrons. The angle between these is going to be 107 degrees. The other molecule that will always, always, always be polar is your bent structure. And that is because the bent structure is always going to have two unshared pair of electrons up here. It's because of these unshared pair of electrons that make it polar. I hope this helps. You can find more on Kim's Chem Chat on both TikTok and YouTube, and I'll catch you later.